In previous lectures, we talked about the formation of the earth, the creation of petroleum, and how and where it accumulated. This all happened millions of years ago. In this lecture, we will discuss some of the scientific techniques and tools that geologists and geoscientists use today to find these oil and gas accumulations. Petroleum exploration is a process that uses science and technology to determine where to drill the first well. Here, I'm going to describe and illustrate these techniques and their tools that will allow petroleum engineers and petroleum geoscientists to see deep underground into what we call the subsurface. With good tools and proper interpretation, we can increase our chances of finding profitable accumulations of oil and gas. But how do we pinpoint the exact location that will maximize our chances of finding producible oil? Before we answer that question, let's examine what is called the life cycle of a well. The first stage in getting oil and gas to market is called exploration. This is where the geoscientists and the petroleum engineers work together to locate and drill into a location that they think will produce oil. After they find traces of oil and gas, they must appraise and evaluate the commercial potential of that discovery. In doing that, they determine how much oil is available, the type of oil and gas that is present, and the extent of the field's size. In a sense, they calculate if there is sufficient petroleum to justify further investment. In other words, will the field produce enough oil to help recover all the costs and still make a profit? Will it be commercial? If they determine there is enough oil, they will then plan the development of the field. They select where wells are to be drilled to determine the size and extent of the field. Next, they plan and budget the equipment, tools, and manpower needed to bring the field into production. When all is in place, the production phase begins. This is where the field starts to produce oil and gas, where it starts to actually make money. In fact, the production stage is the only stage that makes money and must make enough to support the other phases and still make a profit. This stage can last from a few years to decades, depending on the size of the field. When there is no longer enough producible hydrocarbons to make a profit, the well will be shut down. Before it is abandoned, however, there are environmental concerns that must be addressed. It should be the goal of all oil professionals to leave the well sites of an abandoned well in the pristine condition that it was found before drilling began. In the next several lectures in this series, we will discuss each of these phases in more detail. In this lecture, we will concentrate on the phase of exploration. Let's go back to the question I asked a few minutes ago. How do we pinpoint the exact location that will maximize our chances of finding producible oil? To help understand the process of pinpointing an exact location to drill, let's examine what geoscientists and geologists do. In petroleum exploration, they study the surface and subsurface of the earth by looking for evidence of the lithification of organic material in the rock, the diagenesis of hydrocarbons, the upward migration of oil into a reservoir rock, and the entrapment and accumulation of these hydrocarbon molecules. By using the organic theory of how oil is created, they pinpoint possible formations where hydrocarbons could accumulate. Geologists and geoscientists study the surface of the earth, its mountains, its oceans, its valleys, its plains. They study satellite images of the earth. They look for signs of oil, places where oil seeps to the surface. They examine the rock types, formations, and structures called outcrops, and they use the process of elimination to eliminate or cross out areas where they cannot get access, or areas that they know through experience will not contain oil, like areas only made up of igneous or metamorphic rock. Let's examine the methods they use to study the surface of the earth in a little more detail. In the first method, they look for signs of oil on the surface. An oil seep is an area where the oil trap has been broken and oil is now seeping naturally to the surface. For thousands of years, people have been able to use the oil that sits in pools and tar pits on the surface of the earth because this oil was easy to find. As you can see in this illustration, gaseous components in crude oil have evaporated, leaving these heavier tars. Nowadays, geologists still look for these seeps because they suggest that trapped oil may be present nearby, that black marine shale or other source rock might be nearby in the subsurface. In this image of a hypothetical oil seep, you can see that entrapped oil is still present nearby. Here is another example. Oil is trapped but is overflowing because there is so much. This is called a spillover of a trap. Unfortunately, most oil seeps have been discovered and exploited, but there still may be some undiscovered ones in remote, unexplored areas. Since the earth is dynamic and changing, as we learned earlier, new oil seeps can also suddenly appear after recent earthquakes that weaken the cap rock, allowing oil to migrate to the surface. Although new ones are rare, we still must keep an eye out for them. Another method geologists and geoscientists use to study the surface of the Earth's geology is to focus on formation outcrops, the surface exposure of underlying rocks. They endeavor to estimate what might be underneath by studying rock structures that have been pushed to the surface. But how can the geologist know what happens to the outcrop formations that disappear underground into the subsurface? To encourage the investments of money and time needed to drill a wildcat well, the first well that is drilled in a particular area, geologists and geoscientists must offer more evidence or proof than guesses as to what formations of the rocks are in the subsurface. They must struggle to better the odds that oil will be found, on average, in only 1 out of 4 wildcat wells. They use technology to push these averages in their favor. Nevertheless, the oil business is still about risk and convincing others to invest large sums of money in what will most likely be a dry hole, a term we use to describe a drilled well with no commercial oil or gas. This is the symbol used on geological maps to symbolize a dry hole. So why do they take these risks? If they are lucky, they will find a rich field that will not only pay for the other 3, but will also produce a large profit. They are looking for the bonanza. In any event, geologists and geoscientists meticulously compile their surface data to convince others that there are signs of oil and that a closer look may be in order. Geologists and geoscientists also study visual evidence on the surface collected from satellite and airplane images miles high that allow them to view areas over thousands of square miles.